My presentation today will be on non-silicate rock-forming minerals. So minerals play a crucial role in the formation of rocks. There are more than 4,500 naturally occurring minerals that have been documented to date, but of those, only 1% are common in the rocks that form in the Earth's crust. These are known as rock-forming minerals, and they make up most of the chemistry of rocks. And they also account for how they're classified as well. There are two different types of these minerals that are found in rocks. They are known as silicates and non-silicates. Minerals are composed of different combinations of elements, and some are much more common in the Earth's crust than others. Silicon and oxygen alone make up 84% of the Earth's crust, which are what silicate minerals are made up of. So most of rock-forming minerals are silicate rock-forming minerals, but to even further emphasize how much more common they are, silicates bond with metallic ions such as sodium, potassium, calcium, aluminum, iron, and magnesium. Combine these elements with oxygen and silicon, and they make up 99% of the Earth's crust. So it almost goes without saying that almost all igneous, metamorphic, and sedimentary rocks are made up of silicates. The most common silicate minerals, such as orthoclase, it's a type of feldspar. They're used in the production of glass, porcelain, and ceramics. But there is another category of rock-forming minerals, which is our main focus today, that does not contain silicon, that we refer to as non-silicates. These are a much smaller group of rock-forming minerals, but they are an important one and play a big role in our day-to-day lives. Non-silicate rock-forming minerals are minerals that are made up of anything except silicon. These chemical structures of non-silicates tend to be simpler than those of silicates, and how they're formed: ions of common metals bond to elements other than the combination of oxygen and silicon. And even though non-silicates are a much smaller group of rock-forming minerals, they have properties that we take advantage of every day. There are many different non-silicate minerals, and we can separate them into different groups based on how they are formed. So the most common group of non-silicates are carbonate minerals. They occur when various elements are bonded to CO3 to the -2, which is carbonate, and they form minerals such as calcite and dolomite. These minerals make up rocks such as limestone and marble. And calcite itself has more uses than almost any other mineral, and they spread over a wide variety of categories. It has been used in construction since back when the pyramids were built using limestone blocks, and today it is still used as a construction material, and it's used in the form of mortar, cement, and concrete. For hundreds of years, calcite has also been crushed and spread over farming fields as a acid neutralizing soil treatment. Today, it is still used in that sense, except it is heated so that it has a faster reaction rate in the soil. Another use it has as far as acid neutralizing is in streams plagued with acid drainage. It also has other uses such as an abrasive, construction aggregate, pigment, pharmaceutical, and more. Although it isn't something we notice in our everyday lives, it also removes and stores carbon dioxide from the atmosphere, helping us reduce greenhouse gases during its formation. Dolomite is another mineral in this category used in construction. It serves as a road-based material and is used for the production of asphalt. And also, in addition to that, riprap. This mineral also has a use that we don't notice in its everyday life unless you are in the business, but during the conversion of calcite to dolomite, pores are created that fill with oil or natural gas, making it a target for drilling. So just taking into consideration being used in the production of concrete and asphalt alone, only two of its many uses for these materials, we're looking at a $37 billion industry around the world for concrete and a $30 billion industry for asphalt just in the US alone. As said earlier, non-silicates may be a smaller category, but it is most definitely an important one. So sulfides are when elements bond to sulfur, which is S to the negative second. Examples of these minerals are pyrite, chalcopyrite, galena, and sphalerite. Galena is probably the most widely used out of these. It is used for most of the world's lead production. The main use of lead is in acid batteries used to start automobiles. Each contains about 20 pounds of lead and is replaced every 4 to 5 years. There are billions of these batteries sold every year in the US, each costing $75 to $120. That's on average. There's cheaper ones and more expensive ones. Sphalerite, or also known as zinc oxide, is also used in common materials such as galvanized iron, brass, batteries, and mildew-resistant paints. When sphalerite is polished, it has a light dispersion of 0.156, which is more than 3 times better than that of a diamond, which is why it is highly sought out for by collectors. This category plays a part in major industries just as the last category did. Think of how different life would be without car batteries or common household batteries. So this is another important group of non-silicate rock-forming minerals. These are produced by the evaporation of seawater from ancient seas. One of these is gypsum or calcium sulfate, which is used for plaster, plasterboard, as well as a few other building materials. Plasterboard is more commonly known as drywall, and it's used in some form in almost every building built in the U.S. Each year, there are 7 million new homes built using, on average, 150 sheets of drywall in each one. Within this category of evaporate minerals is also a group of halides. This is when an element bonds with halogen. An example of this is halite, which is more commonly known as table salt. This mineral is used for things such as food seasoning, food preservation, and highway de-icing. So in addition to being used to de-ice roads, it's also used to de-ice runways for aircrafts. So this industry alone, and just aircraft de-icing, is 1.3 billion. But if you think deeper into the importance past just commercial airplanes for travelers, it is also crucial for the military in being ready to go at any time and not letting snow or ice delay them. Then as far as food seasoning and food preservation, whether it's added onto your food for flavor or already in it for preservation, the average American consumes 1.6 pounds a year. As of 2016, we had 323.95 million people living in America. That's a lot of salt. That's more than 518 million pounds each year. So there is another material in this category named fluorite. This will probably sound familiar because it is used to manufacture toothpaste, which hopefully everyone uses twice a day. The U.S. toothpaste market alone is over $2.2 billion annually. So our final category of non-silicate rock-forming minerals is ore minerals. These are minerals with important elements such as metals that are extracted from the rock. This category also includes native metals, which occur on their own. And in this category, we have metals such as gold, silver, copper, tin, mercury, and nickel, which nickel can sometimes occur as a native metal, but it more commonly occurs as a sulfide because of its strong affinity for sulfur. So these elements that I just listed off have a huge wide variety of uses, all the way from copper wire to tin cans, but they are by far the most valuable elements. So just to sum things up, in conclusion, non-silicate rock-forming minerals might be a smaller group of minerals, but it definitely plays a huge role in our economy. They're every bit as important as silicates, even though silicates are a larger group.